In this class we want to introduce statistics and see what statistics is about. For a start, there are two meanings. In fact, there are several meanings to the word statistics. It refers to facts in numerical form. For example, income statistics. With income statistics, we may consider the average incomes of perhaps males or females, or average incomes in a certain region or within a certain country, within a certain industry. So there are different ways of looking at income statistics, but it refers to numerical data. Now, statistics also refers to the use of statistical methods. These are techniques for abbreviating and classifying and analyzing numerical relationships within the data. So, having a set of data, we need to understand the data. We need to understand what it's trying to say or what it is saying. We need to find out if there are trends or patterns in the data. Something that is useful, something help us to explain the data. Why is the data the way it is? And there are different statistical methods that have been developed to help us to do this. Some ranging from fairly straightforward and simple techniques to some very sophisticated techniques for forecasting and for data analysis. Nowadays, a lot of the heavy lifting, a lot of the hard work in statistics is done by computers, but the principles must be understood nonetheless. Statistical data. Statistics can only deal with numerical data. However, there are techniques to put qualitative data or opinions into a quantitative form. And social scientists and psychologists and business practitioners have been very inventive and creative in thinking of ways in which, let's say, opinions can be taken into account in some sort of quantitative way and to be processed quantitatively. And obviously opinions are very important. It's, to a large extent, it's opinions that drive the world. But the opinions about a particular product in terms of market research is very important. Do the customers like it? How much do they like it? Do they like the product? Do they like it a lot or a little? These are crucial questions, and if these could be captured in some sort of quantitative or quasi quantitative manner, then perhaps more of an analysis and more of an insight could be gained, and market research would be much more fruitful. So there are techniques, and we'll bump into these later in the course. But for example, say the weather, and the weather could be measured by average rainfall. I agree, that's not the full picture. The weather could be measured by the temperature, or by the humidity, or by wind speed, or there are different factors that we could use. But sometimes people say, well, okay, we can measure it by the rainfall. It gives us some indication of what the weather is like. In terms of attitudes, it may be possible to measure attitudes in terms of some sort of scale. So if we wanted to know the attitudes of people towards a product, we might be able to put down some sort of scale and try to measure it on a scale of whatever. So say we have a scale here. We've got 5 points on this scale. Now we could assign some words to those 5 points, and we could say, well, 1 is I dislike it. I dislike this product. And 5, I like it. 4, I moderately like it. 3, I'm indifferent. It doesn't matter to me. I don't like it and I don't dislike it. I don't care. So we have a scale for measuring opinions, and that's very useful. there are lots of criticisms of it and lots of issues in using this, and it could be dangerous if it wasn't used correctly. And for that reason, there is a literature, we call it a methodology, a method for applying these techniques that is recommended and should be followed. So just devising a scale is not sufficient. It should be properly constructed, well thought out, it should be piloted. There are many aspects to using a scale like this. But as far as we're concerned in this little talk, we have a technique for measuring opinions, which is subjective, and we're capturing it quantitatively. So it comes under the umbrella of statistics. Now, the use of statistics. Well, statistics is vital in the case of business. I suppose in many respects business is quantitative. There is an output which is measured, there are costs which are measured, there are expenditures which are measured, and incomes, and so on and so on. And it's also the case that the business community would like to know what the trends in the market are, so as they can position their product in the market to capitalize on any trends. But in using statistics, there are issues, and the first issue we'd hit here is the statistical problem must be clearly stated. So if we have some data that's been collected, we need to know the purpose. What are we going to do with it, and what is the problem? So the problem must be clearly stated. For example, suppose you were asked to collect some data on consumer expenditure. That seems a straightforward question. Go collect some data on consumer expenditure. Now, if you look down on this slide, the list of items that need to be taken into account, and that's not a comprehensive list. I'm sure if we sat down and thought about it more carefully, we could add to this list. But what data would you collect? We want to collect data on consumer expenditure. Would you check the capital city only? So if you lived in the UK, would you check London only and ignore all the other places? Because consumer expenditure in London might be different to the other places. Or would you just focus on cities and ignore the towns or the countryside? Because maybe different patterns of expenditure again. And you'd be losing that. You would lose that sensitivity. Would you just look at males or females or both? Both types of consumer. It's an issue. Would it look at expenditure on just on necessities or on luxury expenditure? Would it look at all consumers of a certain age? As we get older, as we all get older, our patterns of consumption change. So when you're 10, you have certain priorities with your limited income. And when you're 90, you have certain priorities with your limited income. And they're not the same as when you were 10, I presume. So there's a whole list of issues that we need to consider, and just have a look over those. The upshot of all of this is that statistics requires clear questions. The question posed in the example I've given there is not a good question. It's too wide, it's not clear, it's not defined, there's no brief as to what should be looked at. And statistics requires that statistical problems are clearly stated. Second, how do we collect data? We would have to collect a sample from the population. The population is whatever it is we're looking at. If we're looking at consumer expenditure, our population would be consumers. So the people who are not consumers are not part of our population. So the population is the relevant data under consideration. So we only test some of the population. Now, the problem is, how do we select which ones we're going to ask? And again, later on, when we look at methodology and we look at sample selection, these will be big issues. Obviously, if you collect data with a bad sample selection, the errors will mean that the whole exercise is probably futile. So the word here we got to watch out for is bias. If the sample is biased, then the results will be biased and maybe worthless. In fact, the results could be dangerous. So for example, suppose we wish to find out how long a certain type of light bulb lasts. Suppose that the population in this case is 1,000 light bulbs. So we're given 1,000 light bulbs and we're asked how long will they last. Well, we can't test the 1,000 because if we did, there'd be nothing left to sell if we were selling light bulbs. So what we may do is draw a sample. Let's say we take 40 and put on the 40 and let them run and time how long they last. The sample size would have to be sufficient to give a good set of results. The way we selected the sample would have to be done properly as well. But as I said, we'll talk about this more fully in different videos. For the moment, just bear it in mind. The data collection. There are two forms of data. There's primary data and secondary. Primary data simply means going to the source of the data, going right to the source, collecting it firsthand. That's primary. Secondary data involves using published data. So for example, if you go to government statistics, the government's already collected the data for you, you're collecting it from them. So it's secondary data. It's been collected the first time by the government, that was primary. But then you're collecting it from the government, that's secondary. So secondary is when you didn't collect it yourself from the source, you just simply collected it from someone else or from some other source and used it from there. So there are two types of data we need to be aware of, and that's very important because we're constantly talking about primary and secondary data. Data organization. Sometimes the data needs to be coded, and coding it may be a problem as well. Again, a video later in the course, but we might want to code it as yes is equal to 2, no is equal to 1, and don't know is equal to 0. This does not mean that we should take averages and work out statistics like that, because if we took an average between what we've got on the screen now, y equals yes and no equals 1, and we took two people, one said yes and one said no, and we averaged it, we get 1.5, which would be a pretty meaningless outcome. So by and large, common sense has to kick in, and we don't take averages and we don't process the data as if it was proper, in inverted commas, proper numerical data, data which is naturally numerical. And the analysis and interpretation of data, again, common sense needs to kick in. We need to have the proper technique for the analysis, not just any technique. For example, in statistics we often try and fit straight lines to sets of data to see if the trend is some sort of straight line. Well, let's say the data was what we call curvilinear. Let's say it was a natural curve. It was a nice curve, well following some sort of geometric shape. Let's say it could be a quadratic, for example. Quadratics are not straight lines. They're conic sections. Well, in that case, fitting a straight line would be silly. So sometimes we use the wrong technique, which will give bad results. And when we've interpreted the data, if we find a trend, and we found a trend for the last 10 years, does that entitle us to continue the trend for the next 10 years and say this trend will continue as it is the last 10 years over the coming 10 years? Not really. But we have to be just careful about our interpretation. Again, more later. Presenting data, well, this is a bit more subjective, but with the advent of nice presentation packages for computers, presentation has become a lot more interesting. And then we have report writing, writing up about what the methodology was, how the data was collected, what type of data, was it secondary or primary data, what issues were encountered in collecting the data, what technique was used for the analysis of the data, and finally the presentation. In management, statistics is very important, as I said to you earlier. Financial statements and the work of accountants rely heavily on statistics. Good management decisions need to be supported, if possible. So management draws on statistical analysis to facilitate a whole range of decision-making process. For example, stock control and projecting demand for the product into the future, looking at demand from the past and looking at trends and seasonal factors and so on. Market research to try and find out how does the consumer see the product and what improvements can be made to the product. Quality control, making sure that the number of defective products leaving the factory is not significant. So testing the products to make sure that the products meet the standards, and what proportion should be tested, and what technique should be used for analysing the results to see if the number of defectives are significant or not significant. Looking at sales trends, just developing what's known as a scatter diagram and plotting it on the diagram and having a look at the shape of what's happening over time. Are sales increasing or are they falling? Now, stock control. Well, large companies, or many companies, doesn't have to be really large, many companies have significant capital invested in stock control. And holding that stock is a costly exercise. Capital is tied up in it. Capital that could be used for some other purpose. It's what an economist would call an opportunity cost. Therefore, the ideal amount of stock should be kept. It should not be overstocked. It shouldn't certainly be understocked. If it's understocked, when consumers come looking for the product, it won't be there. Market research involves talking to customers, perhaps looking at potential customers, analysing the data, and trying to find out what the right price is, trying to find out what the proper design is, trying to find out the attitudes to the product, looking at competitors in the market and what their prices and their products are, and doing some sort of data collection, survey techniques to try and assess a product against its competitors perhaps, or just taking information back which can help the decision-making process. Quality control, well, it's important that the number of defective items leaving the factory is not significant. And what I mean by significant is a technical term in statistics, which we'll talk about again in later videos. But the idea here is that the reputation of the business is at stake. If the business is sending out defective products, customers may become alienated. So it's important for the business to be able to sample perhaps its output, if it is a physical output, that is, be able to sample the output, check it for quality, see how many as a proportion of the sample they've taken are defective, and trying to calculate if that is significant. What if that figure applied to all of the output of the factory? How many items defective would there be in a year, or in a month, or in a week, or whatever? And that could be significant. There's a lot of information on the slide here, so I'd invite you to stop the video at any time and just read over the slide and make your own notes. Sales trends. Well, as I said earlier, marketing is an essential function of the business, making sure that the product is in the right place and positioned in the market correctly, making sure that customers see the product for what it actually is, and making sure that the product addresses their needs. To do that, information should be sought from the consumer, types of market research, and fed back, and then looking at the sale trends that ensue from that follow on from that. If the sales are steady or increasing, it looks like in that case something positive has happened, something good has happened. If the sales are falling, then there's something wrong. Go back to looking at the product, looking at its position in the market, interviewing perhaps a sample of customers and trying to find out what it is that's gone wrong. That's why selecting the customers is so important, selecting them without bias. So the techniques that are employed in statistics are very important to make sure that as far as possible it's unbiased and there's some sort of objective figures coming back to help management improve their decision making. Okay, so I think that's an introduction to statistics and the importance of statistics. Please have a look over the slides in more detail. Perhaps stop the video as you work your way through it and just make your own notes. And check out some of the points I've made online. Just go into Google and see what other people online are saying about these ideas. But for the meantime, that concludes our talk, and thank you for watching.